Welcome to this video. Let me check my audio first. Okay, welcome. This is Said Ahmed from Toronto, Canada. So what this video is about. Okay, so this video will be on stock market prediction, stock price prediction using some machine learning, deep learning, graph learning in combination. So we are sort of doing it, right? Now I was away from it for some time. So now I will need to go back and see what I did not do, or what needs to be done. Then I'll take it from there. So this particular video, it is just catch up. Just catch up what I did and try to see what is where, and then try to go to the next step, right? So yeah, in the meantime, I think probably yesterday I did little changes, not too much. So little changes, I believe I did on some sort of presentation type of things. So from the project to taking some information, the presentation, and I believe I created on video how to create one of the diagram in the presentation, or that also shows the steps in this project, right? So okay, now so how do you do? Try to catch up, right? Try to catch up, see what we done. I'll probably show a little bit of the presentation so that we know the steps and how we are doing, and then little bit of changes that I made, not much, little bit. So for the sake of creating a diagram or to put information from code to the presentation. So there are some steps. So we'll review that, and then yes, the goal is to go to the next step and try to find out what I want to do. And in this video, I may not do it, but probably in the next one. Okay. In terms of where I want to go, it looks like I was so far, I believe it probably is almost some days, but maybe around a week. Anyway, I think I was doing some, probably more than a week, I think. Let's say. So I was trying to do a third strategy of stock price prediction. That's probably where I want to start and then take it from there. Okay. So I'm just trying to go to the YouTube channel where I kept it. Okay, SaLearningSchool-SitesTree. I'm just searching my YouTube channel. So I believe I can share now screen. Okay, so this is the playlist. Okay, I believe this is the one. So yeah, I think we're doing some financial news based. It's one of the strategy. And this is the one that I created yesterday, I believe. It is for the presentation. Okay. So that's for next step. Yes, we'll need to, I want to catch up and then go from there. So let's also share the presentation document that actually will give a overview, and I believe I might get some clue in terms of what to do or not, or where can I take you next. So in terms of share screen. Okay, so this is the one. Okay, so yeah, these are the different approaches. Those are being used for stock price prediction, right? So this is the graph base that's the topic of this project and this presentation. These are some other ways. In this, we will be comparing, I think this paper is compared. We may or may not compare. I think what I will do in my case, I will compare my implementation with the paper implementation, right? So with some variations. So these are the steps that I followed. And in general, these are the steps that you follow to develop in a data analytics or machine learning or deep learning project, right? This is almost the high level thing, right? What will be the difference? Let's say this data collection, data exploration, feature selection, graph generation. Okay, this probably will come down to when it is graph neural network or graph mining. This will come. Yeah, this graph generation will not be in other machine learning or data analytics projects, but it will be only for the graph related things, right? So, but modeling, yes, feature selection. There can have one thing: feature extraction, feature selection, feature extraction, and then modeling, right? So graphs, yeah, something may come here depending on the particular project, right? In general, then experimental design results discussions, right? That's how things go in general, right? Now, even if this is the basic steps, right? Still, you may want to create this methodology diagram because for your project, you may be doing some specific thing about it, right? So that's what you need to capture in the methodology diagram as well. See, data collection. Data collection, what did I do? I tried a database, I believe it's Yahoo or Kaggle. Okay, I think as far as I remember, the last time I checked, it was from Yahoo, right? Okay, I took the data from there. At one point, it did not feel right, so I used one of the Python module, yfinance, to scrape data from Yahoo, right? So data collection, I believe I need to put something more here. Data collection, right? I need to put something on the data collection. So yes, data collection, that is the, in general, I believe I did read a book where there is a big chapter, a significant part of the chapter, data exploration and data sense making, or yeah, it discussed a good amount of information in the data sources, data collection, where can you get the data, or how to, or where you can, how to create the data when it is not or not. So there is a good amount of information. So in your methodology diagram or in my diagram, I believe I could keep a little bit more information. Data collection, right? Let me see. I created this diagram using some TKZ package in the latex. I believe the immediate before video of this you will see that I showed how to use the latex to create this kind of diagram. I'll open it in the background, and then I will add something there, right? Okay, because I'm here, let me share that one as well. Okay, so this is where I wrote the data collection thing. Data collection. So in my case, I can say finance. Okay, I can suggest scrap data from Yahoo Finance using finance. Okay. In the methodology diagram, you need to give core information, not all the information. Okay, let me see. I sort of tried not to mention it, but I really did teach courses on data analytics project development. Sure, definitely I discussed about this methodology aspect, but if you are happen to graduate student or some whatever courses you're doing, you're trying to create methodology diagram. Yeah, the thing is, you just want to give the core information and enough information, not to make a diagram a total descriptional paragraph. No, right? Scrap data from your finance. Okay, using finance, it may not be that important. You could just say data collection, Yahoo Finance, right? That could be enough information. data collection. Okay, data collection. Yeah, we can use it, or in some cases you can just say data, right? And sometimes what happens in the industry when you work with data analytics projects, the company might have existing ETL process, data lakes, or all those things set up already there. You could take data from there, right? But if you're not, you need to scrap the internet or some other sources to collect data. Yes, I did work in the industry data analytics projects when I needed to scrap data from government website or a Google Trends or some Twitter. Those things are there, right? Anyway, so my goal was here just to say that this. Okay, that probably is the only thing that I want to do here. So data collection, scrap data from Yahoo Finance using Y Finance. That probably is a little bit of scrap data from Yahoo Finance. I don't think I need to say all the details. If I just say from Yahoo Finance, right? And using Y Finance module, that description can come in some other areas, right? In the methodology, just keep the main ideas. And another thing is, because I'm also showing the presentation, right? In the presentation, you can give the details, right? Or in your writing, when you'll be if you are supposed to write some report, then the description you can give me the more details, right? Okay, now I will take the image from the. Okay, at this moment, I'm not really sure that you can see my screen on this. Let's see. So share a screen, entire screen. So this is what it looks like, right? So this is the text file. If I execute it, so this is how it looks like. Okay, now I will take it from here, delete, and put it there. So you can see data collection from this, right? Okay, still I don't think I want to share the entire screen. Okay, data exploration. Okay, initial data analysis and exploratory data analysis. I believe I will say it initial data analysis and exploratory data analysis. I think it relates to cleaning and replacing or trying to show the data characteristics univariate, bivariate, or correlation heat map. There are other things you can do. Yeah, that probably is a common thing. In my cases, I needed to deal with the if data exists for every day, and for each of the day data exists for each of the stock, and all of the stock has some data from the one duration to another duration. And also because I'll be comparing with the research paper, so I have the data, the research paper used for the duration. I didn't have the exact data, but I think at I tried to go as close as possible, just trying to collect the data for the same stocks for the same period of time, right? This also, it probably will be on the initial data analysis or exploratory data analysis. It will fall under that. Okay. So, and in terms of let's say sometimes unitary or uh, bivariate analysis. Let's say in my case, I can explain some of the things that I did as part of unitary or bivariate analysis kind of things, right? Let me see. I tried to see for each stock for the price. Does it have price for every single day during the period? Or what else I did? Let's see. So I have multiple different stocks, right? Multiple different stocks and they have their prices for many different days, right? Now, one thing I wanted to see, the first data set that I initially worked with, right? So they have data from probably 1977 or 1980, from there 2022, those kind of things. I believe I'm almost right there. But not all stocks had data for all the period. Now, what I needed to see, I needed to write some script to see what is the minimum date. What is the minimum date each stock has data from, right? And among all of the minimum days, what is the maximum? So that if I take the data, I start at a date when all of the stock has some data, right? Okay. And also, all of the stocks, what is the maximum date they have data for, right? Now, among all of those maximum, I try to go to the minimum of the maximum date, so that within that period, all of the stocks will have some data. I checked individually and also in relation to each other. Those probably will be falling somewhere in that area, right? So, and then between them, I try to select some particular couple of years to take data from there. Then I try to see if each of the stock has data for each of the day. Each of the stock has data for each of the day. It did not seem completely okay. This probably I will say to some almost good, but not perfect. Probably, okay, I probably will say 9, 10 of the data probably were not uh, aligned. Okay, so I thought that could be enough, but ideally even further exploration is required, or ideally, I'm not really sure if I try to insert something. I might have tried insert something for the missing day for particular things to align it, and just some sort of interpolating or some other ways. I don't remember to what extent I went into direction at one point. I abandoned this data set. I scrapped from the Yahoo, right? So those are some of the things that you need to do, right? And in any machine learning project or any data analytics deep learning project, we always say that garbage in, garbage out, right? Garbage in, garbage out. So you need to make sure your data is correct, right? If you don't get good output, one of the important steps will be going back and taking a look at your data. Definitely the methodology, model, all other things matter, but at one point, data always is a concern. Data will need to be proper, right? Okay. So yeah, in the Yahoo Finance, I saw that I was supposed to work with 30 stocks, but I think 2 of the stocks, they don't have data in the Yahoo Finance for whatever reason. The company probably is no longer there, or probably Yahoo don't collect data for them anymore. Those kind of things. Okay. So, and I also saw that, okay, so in the data is some sort of missing. So I needed to discard those particular stocks. And then probably there are some places where some dates where the data were not there, or missing or null, or those kind of things. I needed to some sort of interpolation thing. For stock prices, interpolation can be a good thing because surrounding prices can give a good indication of the missing prices. It won't be perfect, but that is highly likely, right? I think one day large movement, that is very rare. That is very rare. I'll not say very rare, at least rare, right? So interpolation can be a good thing. Or if I could try to get data from different sources, that could also be an option, right? And yeah, provided the stock market was open, right? The data could be somewhere else. Okay. So feature selection, I did not need to do much because in terms of there are 4 or 5 columns, but what I needed the date and the closing price and the stock ticker. That's the 3 things I needed to do. Okay, so when I was scraping from Yahoo, I can just select particular field, right, that I could do. But when I was using the other one, it had more columns, so I needed to remove some columns to get the exact things. Another thing is that adjusted close and close. These are 2 different things. I think I could try with both of them. Which one? Adjusted close apparently seems the right column to work on. And again, I'm not a finance guy, so that's the best understanding. And definitely I have some familiarity with stock market and dealing with stocks and all those things, but I think still, I'm not a finance guy, right? So graph generation. Okay, from that data, I create some graph depending on the uh, relationships among the stocks. Pearson correlation. Okay. Another thing is data, right? Okay, the data collection. One more thing I need to mention. Data collection, I may not just say data collection. I probably want to remove the collection. I will just say data from Yahoo Finance. And another thing is news articles, right? News articles, that is also, those news are also from Yahoo. Okay, I believe I downloaded the data from Kaggle this time for sure, but that was from financial news article. So these are 2 different set of data. So the first data set, it created the Pearson Spearman Kendall Tau based graph, and the finance news data that helped me to create the financial news based data and the corresponding graph, right? Then I will be applying my model on the data for the stock price prediction, right? Now it looks like I need to change the diagram one more time, right? Okay, price from Yahoo data and finance news. Okay, finance news data from Kaggle, right? So I'm just modifying my text and then I'll create the picture and bring it back. Okay, by doing this explanation, I'm getting more information. I think, it gave me some clue what I need to change in the diagram, right? Price from Yahoo finance news data from Kaggle, finance news data or financial news data from Kaggle. Okay, I'm fixing the diagram. Okay, what am I sharing? I believe I was sharing the PowerPoint. So, okay, change it here. Okay, modeling, different modeling. So different approaches that I used. The closest GCN, CNN plus MLP, that is the closest to the paper, right? However, the paper used multiple blocks. Until now, I use just one block. I think the paper shows one block that has GCN, CNN, right? Another block, GCN, CNN, and then the MLP, the diagram. But in my case, GCN, CNN, MLP, right? That's, yeah, I was trying other GCN only, that's what I tried. Deep graph NN, kind of to say if I modify deep graph NN to create the GCN, CNN, MLP or not. I believe that is highly likely. GCN, LSTM, that probably is something I have to try. Okay. So modeling the experiments, in my case, what are the variations of the experiment, right? Yeah, different model is different experiment. And experimental setup platform comes under experimental setup. So far I'm running on my laptop. I have another source, I think Google Colab, and there is one other place that I could run. Probably they have GPU. So yeah, for my case, yes, GPU, the high performing machine could be good, especially when I saw that when I use epochs like 20,000 or 22,000, 25,000, then I get good data. Actually, in the beginning, that's happened to be the case when I was using the other data set, right? Now, it probably is not that bad. I need to recheck again how far, where exactly I got the data. It might be 10,000 or it might even be 5,000 epochs. In that case, I probably don't need a very high-end machine or server or something like this, right? But still, it doesn't hurt if I have a different server where I can put it and it runs there and I do my work here, right? So that it is better. But anyway, so when you report your work or when I report my work, in that case, different configuration and how it works in different platforms, that can be one experimental setup, right? So it also shows how practical it is, or if someone wants to use it in reality, where they can use it, right? So that is one thing. Hyperparameter adjustment, and probably I use some sort of learning rate. That's probably one thing that I can change and see which learning rate gives me the best prediction and takes less time, right? So yes, those are different experimental setup that I tried or will try or do something, or you can also try depending on your project, right? Or sometimes let's say the paper, they also try to do it. I think similar things, similar experiment, different experiment. On top of that, there is some ARIMA or some Luvian community-based history predictions and all those uh, some other things, right? We're not going there. So yes, results, root mean square, MAPI. Okay, that's probably what I was doing, right? Okay, so in this slide, I talked a lot, right? But if you are giving a presentation in real life on your work, you probably will give in 10, 15, 20, it's maximum half an hour. I don't think in general presentations will go more than half an hour unless it's an industry conference. Yeah, in industry conference, you might have something more. I'm not really sure. It always depends where, how, what. Okay, this is the graph that I created from this stock price data. This is the financial news. I think in financial news, I have around 15,000 news articles, but the paper itself used articles around 1,000,000, right? Okay. So our result will not be close to the paper. Now, one thing is the flavor of the result matches, but the result itself will not be as perfect, right? The flavor, what do I mean? The paper, they found good performance when there's a stock price prediction using financial news. The similar thing will happen for me. But in terms of the how close the predicted price, the RMSC, my thing will not be as close, it will be higher. Okay. Now, yeah, I think they found most with financial. In most cases, I will also find the financial, and then they found the candle tau, the second highest, second best. In my case, it may not be always the truth. So far, what I see, but things will change, right? Sometimes probably candle, sometimes probably spearmint, depending. So yeah, sometimes probably even Pycharm was working as close. Okay. Okay, let me see. Okay, so this is what I'm doing. Okay, models and platforms. Okay, this is the models and platforms that I was using. Okay, there is some. With this slide design. Okay. Okay, what happens is you need to same with platform. Okay, one good thing about GCN plus LSTM, some libraries I checked stellar graph that has this thing into it. So you could use it. The one that I'm trying to use GCN plus CNN, multiple blocks of them plus MLP. So this is not something built in. Now you could use Keras, TensorFlow, similar thing to build those layers from scratch. That is one option, right? So one layer of GCN, one layer of CNN, and repeat those to create it, right? So that what you can do. And one another implementation option. One other implementation options is equations. Let's say GCN or CNN, what sort of equations they use, you could try to utilize those equations as well to implement your work. I said there are some couple of examples they uses those equations. Yeah, but that's not what I am doing right now. I may try one of those things that is using this equation thing, at least to know. Yes, I think in several cases I might have tried to implement some models using some equations, but not for this. So simple things. Okay. So this is the results that I found. This just shows your loss, MSC, MAPE, mean square. So this is the MAE, mean. MAE is the MAPE, mean squared error. Okay, this one is in GCN plus MLP. Okay, it is just performance. You can see causation is usually lower. Okay, 10,000 epoch and 1,000 epoch. Okay, it looks like 1,000 epoch perform better. Okay, only Spearman that performed worse in 1000 epochs, otherwise it performed better. And MAPE, I think it probably will need to be seen in terms of context on its own. Separately, it is not seriously important. Okay, this is the training and validation loss, okay, when I'm using GCN plus CNN. And definitely there will be some MLP. MLP does the regression and the corresponding stock price comes after MLP. GCN plus CNN plus MLP performance for that purpose. Here it looks like Spearman performed the best. These are the data for those. Yeah, 1, 2, 3, 4. One is Pearson, Spearman, Candle, and News. Spearman looks like here performed the best. So this is the architecture of the paper. And in my case, this is the architecture that I am trying. Okay, now, one thing is when you're comparing, you may try to implement what the paper has done and see if your implementation can do that. Okay, this is the closest one. GCN, CNN, then MLP. They have used multiple blocks. I just used one. And another thing is the paper did not mention how many layers of convolutional neural networks they used, right? This GCN, the Stellar Graph Library, it uses some, let's say when I say GCN 32 something, right? So those things are there, but they did not mention exactly what they used or whether they did it from the scratch or whether they used any libraries. I didn't get much information. So yeah. Okay, ranking of performance. Okay, this is a rough. I think when I was changing this slide yesterday, so it seems what it is now. I think is different experiment might have given it different ideas, different grading results. So I probably will need to see which one does better in most of the cases, right? So I will rank it in that order. But as the paper has this order. And I thought I can just compare is the specific numbers using this paper in my approaches. So paper, GCN, CNN. What can I say? GCN, CNN. I think in regular expression, we probably sometimes use star to show 0 or more or plus. Okay, let me see. Probably I can say that GCN plus CNN, multiple blocks, and then MLP. These are my numbers. I think I sort of took it from their images, plots. It may not be exactly correct, but it will be very closely reflect. It is a 3 time steps. I took it from there. And these numbers, yes, Pearson, Spearman, Kendall, News, this architecture. This is deep graph, CNN, right? Now, I actually took this number from my implementations, this, right? I just copied and pasted. I think I wanted to create the template layout and wanted to make sure that I have the right size cell in it. So I just created the layout where this data is from the actual experiment. These are just copy, right? So you can say this is 12, mine is 62. So my RMS is higher. So it means my correct, I'm not as closely correct like them. right? In that case, I need to modify the model, and also epochs, learning rate. Those are a couple of the areas that I can check. And in terms of pricing, in terms of data, price data is price data. Not that I can change much, and there is not much missing data. So there is not too much I can change it there. Now, one thing is whether I want to normalize the data or not. My one thought was stock data. Okay, if I think scaling can reflect the interrelation or the how much they vary to each other in normalized form, yeah, I believe there will be some benefit in doing the normalization. Now, whether normalization will affect the uh, regressed stock price or not, that probably one another area to take a look, right? Let me see. So, yes, the point that I was making that I need to do more variations and then see how close I can go to the paper. And another thing is they used uh, multiple levels of this. That means the modified graph structure, and they used that for the next block. In my case, GCN itself has lots of layers that I'm using from the stellar graph. Now, what they did, that's not quite certain. So there are some variations and similarities, but eventually my goal is going close to the paper and trying to make it better, right? So in general, in this case, the news article probably the second closest, second to lowest, not in this case. Okay, this might be the lowest of all. Anyway, that comparison will come later. Okay, these are my challenges. Implement exact architecture. And then now find or generate, especially for the financial news. So that was definitely a challenge. Implementing exact architecture, yes, that was a challenge. Exact platform to execute. Yeah, if I want to compare, this is definitely something needs to be considered. Now, if I had a better platform, I could get execution result faster, and I could do more of it to do more work to see how close I can get, right? If my platform is slower, I cannot get it. Another thing is if you want to compare, then platform matching can also be another. Okay. Okay. So it was a feature from there. In my case, yes, definitely this is something to do and then do this, right? Okay. This looks like I'm giving the where we are in terms of the presentation document. I did not open the coding side. Let me open it. Okay, that probably could be another video. Okay, I'm closing it. I believe the coding changes and the next steps and catching up in terms of coding that I can do in another video.